Hi again. In this video, we're going to find a Bootstrap confidence interval for a proportion, or several of them actually. So we are going to use the stat key Bootstrap, oops, I found a typo there, Bootstrap confidence interval for a single proportion. Okay, and we're going to select the Reese's Pieces data set. We want to estimate the proportion of all Reese's Pieces that are orange. Okay, so in case you're not familiar, they come in three colors: orange, yellow, and brown. Okay, do you think the colors are all equally? Is it a third, one third, one third? I don't know. Okay, so let's go over to stat key. Oops, that didn't do it. Okay, here's stat key, and you can go directly to the link, or just wanted to show you we're in the Bootstrap confidence interval column, and this time we're going to select single proportion. Okay, so in a question you might need to decide, am I going to a proportion or a mean? So which one to go to? Okay, so they have some built in, the one for means does as well, so you might be directed to go to a particular data set in a question. So we've got Reese's Pieces orange right here. And now you might notice this one looks a little different because this is a proportion. So we have our sample size of 150. That means they took a random sample of 150 Reese's Pieces and they counted 72 of them were orange. Okay, so this gives us a sample proportion, or a p-hat, of 72 out of 150. Okay, so it's a little different than when we had the 8 people in our little image for our Bootstrap simulation, but it's similar. Think of if we had 72 out of 150, so every 72, we're still treating our population as many copies of our original sample. So original sample, so every 72 out of 150 are orange, okay? And we're going to be resampling out of that 70, out of the 150. We're going to be resampling and see in the same sample size, our resamples are always the same sample size, and see each time what proportion are orange, okay? So again, we'll do a few individually here to give you an idea of what it looks like. So this time we got 71, very close. 71 out of 150. 68 out of 150. 70, 65, 73. So you can see it's bouncing around a little bit, but not too far. Oh, we got an 83, so that was on the higher side. Okay, I got 10, so I'm going to do some 10s. Go ahead and play around with this. It's really fun, just like the sampling distribution. But remember, we're resampling from our original sample. That's what bootstrapping means. It's like we only have this one sample, so we've got to make do with it. Okay, I'm going to go up to 200 and go by hundreds. I bet you are seeing a familiar shape, huh? 1,000, and I'll do another 1,000. Okay, so we get our bell shape, and depending on, let's read the question to see which method we're going to use, right? Are we going to use the standard error, or are we going to use our percentiles with the two-tail? Oh, notice also there is a option to do proportion or count. So count would be just the actual number in each sample, 70, 71, 83, 75. We're more often doing proportion though. And then it turns it into a percentage or proportion. Okay, so let me go back to the paper for a second and figure out what our question is. Okay, so just to show what is going on for future reference in your notes, the original sample says 72 out of 150 are orange. We generated 200 Bootstrap samples, and we're going to use this distribution to find each of the following confidence intervals. Okay, so the first one is a 95% confidence interval for the proportion of orange using the Bootstrap standard error. Okay. So for this one, remember that's our p-hat, plus or minus 2 standard errors. Excuse me. Okay, so let me go back to that and write down what our values are. So our p-hat, our sample statistic always comes from our original sample, okay? Not the bootstrap and not the distribution, the original sample. So that is 72 out of 150. So I'm going to write that down. And then I'll show you in just a minute. And then we also need our standard error. The standard error comes from our bootstrap distribution. Remember, this is our estimate of sample to sample variation. So our standard error is 0.041. Okay, let me show you what I wrote. So our p-hat is 72 out of 150. I'm going to divide that in a second. And then plus or minus 2 times our standard error, which was 0.041. Okay, so let me go ahead and get a decimal for p-hat. 72, it probably actually was in the, it's probably right on the screen there. I just wasn't looking at it. 0.48. Let me just check. I'm sure it's, yeah, it's actually right there. So you could just read it right there, 0.48. But I think it's also helpful to remember where that's coming from. Plus or minus, now I'm going to multiply 2 times my standard error, 0.041, 0.082. Okay, and now I can go ahead and subtract and add and get the confidence interval. .48 plus 0.082, I hope you can see that, is 0.5, oops, sorry, let's usually try to do the minus one first. 0.48 minus 0.082, I was distracted by trying to get the calculator on the screen, 0.398, and then I already added them, that's 0.562. Okay, so we're 95% confident that this interval captures the true proportion of orange Reese's Pieces. Or if you prefer to write it out as percent, 39.8% orange to 56.2% orange. Okay, do you think it's a third, a third, a third? Okay, let's see what the next question is. A 95% confidence interval for the proportion of orange using percentiles. Okay, so that's our two-tail checkbox. Same confidence level. Let's go back. Oops, I keep doing that. Okay, check on two-tail. We could regenerate it, but we don't have to. Every time we're going to get a slightly different thing. So now we're getting 40% to 56%. This came up 95% automatically. So let me write that one down. 0.40 to 0.56, or 0.40 to 0.56, or 40% to 56%. Let's compare. They're pretty close, right? 39.8, 56.2. So they're about 0.2% off, which is not too bad, right? Okay. You're welcome to try the rest and pause the video and try the rest and come back if you want. A 90% confidence interval for the proportion of orange using percentiles. Okay, so percentiles versus standard error. That's how we know which way we're doing it. Also for 90, we have to use percentiles. Let me go back to here. So we're going to change our middle percentage number or area number here to 0.90. And notice it gets narrower because we have the middle 90% versus the middle 95%. So our numbers should come in, right? So now we have 0.413, comma 0.547. 0.413, comma 0.547. Or 41.3%, comma 54.7%. Okay, so hopefully you're seeing a pattern between the confidence level and the width of the interval. Let's do one we haven't done before, an 85% confidence interval for the proportion of orange. Clicking back on the applet, clicking my middle number to change that to 0.85 for 85%. Comes in, I love this visual, it comes in even more, doesn't it? 0.42 to 0.54. Let me write that down. .42 to 0.54, or 42% to 54%. Okay, so 95, 90, 85. Question E is asking us, what do you notice about the width of the confidence interval and the confidence level? Okay, so we kind of were looking at this with a graph, right? So 95, 90, 85, the confidence level is going down, and this is also getting wider. Wider or narrower? It's getting narrower. I like to look at the picture. Let's go back to the picture. Okay, so when we have the middle 85, that is narrower than, let me change this to the middle 90. Okay, so it's actually, yeah, it's getting narrower. Sorry, it's hard to tell with the decimals sometimes which way you're going. It's getting narrower because if you think of the middle 95, change it back to 95, that's wider because we're capturing the middle 95, so 95% is going to be wider than the middle 90%, wider than the middle 85%. Okay, so that means the larger the confidence level, the wider the interval. And of course, I want to make a caveat here that this is keeping the same sample size. Okay, keeping the sample size the same. Which of course we have to do with bootstrapping, but later on we might be able to change our sample size as well. Okay, so does this make sense? So if we want a higher confidence, we need a wider interval. So it's kind of like if we want to be, going back to the fishing analogy, if we want to be more confident of catching the fish, we need a wider net. Okay, so let me write that down. We need a wider net to be more confident of or in catching the fish. Okay. And then, of course, we always want to practice our interpretation for confidence intervals, but these will be the same wording, so there's no need to write it out that many times, but let's go ahead and pick one. So I picked the 85% confidence interval, just one. Write the interpretation for the 85% confidence interval. Okay, so when I always start out, we can be 85% confident that the true proportion of orange, look at how to spell Reese's, oh, it's E-E, Reese's Pieces is between 42 and 54%. Okay, so it does seem like there's more orange, right? I've been asking the question, do you think it's a third, a third, a third? Well, 33% is not in our interval, right? So I'm just going to make a note here because we'll be asking questions like this later on, so you might see something like this in the homework too. The distribution of colors does not seem to be, I'm going to say 1/3, 1/3, 1/3, because 33.3% is not in, it's not in any of our intervals, right? Let's go back and double check. Even, was it even in the widest ones, which were both of these 95s? No, the lowest we got was 39.8. So it seems like there's at least 40% orange. 33% is not in any of our confidence intervals. Okay, great. Well, I think you can use both of those apps to generate Bootstrap distributions and answer questions and find confidence intervals and interpret them as you have been doing for a while now. And then just one last recap here. Maybe you already know this, so see if you can answer this. What's the difference between a sampling distribution and a bootstrap distribution? The sampling distribution is resampling from the population. So we're taking repeated samples from the population, whereas a bootstrap distribution is resampling from a sample. So we just have one sample, which is in real life, we just take one sample. If we have money to take more, just take a bigger sample and then resample from that. And that's how we get our bootstrap distribution. Okay, thank you for watching, and I'll see you in the next video.